Modifiers are chemicals put into the alloy as points that silicon can attach to start growing from to make a big crystal, or what we call a casting. Modifiers help to keep the alloy from stratifying, which is coming apart or separating when a casting sets up. There are two main modifiers, sodium and strontium. We use strontium because it works better in a permanent mold application. Running the melt temperature high or letting the melt stand for a long time allows the strontium to burn out. We make additions to have active strontium in the melt. For safety reasons, ingots should be preheated before you put them into the melt. Also, if you analyze an ingot, you would find that the elements silicon, copper, and magnesium are stratified. This is because of the slow rate an ingot sets up. Slower setup time means more stratification. Some ingot manufacturers extrude their product. These are not stratified. Of all the alloy choices, 356 represents a very good combination, yielding good tensile strength and elongation properties. There are a number of casting processes: sand casting, die casting, low pressure casting, investment casting, and permanent mold casting, which we do at BPI. The speed for which the casting sets up affects the quality of that casting. Sand and investment casting set up slowly, and the alloy stratifies as it sets up, lowering its strength. Die casting sets up quickly, but the violent turbulence of the metal entering the die creates a lot of oxides, lowering the casting strength. Permanent mold and low pressure casting processes have the ultimate speed of the casting setting up, yielding the highest potential for strength. Think of a low pressure casting as the same as we do, except the mold is mounted directly over the melting pot. Gaseous nitrogen is pressed against the melt, forcing the metal up into the mold from the bottom. Based upon trial and error to set up the time, the pressure is then let off, and the excess metal, the gate, goes back into the pot. The mold is then opened up and the casting is taken out. Hydrogen and oxide films are the two biggest items that damage metal quality. While keeping hydrogen low in the melt is important of all the casting processes, the speed of the casting setting up in the permanent mold process makes it less critical than other casting processes. Oxides can be reduced by pushing back the obvious oxides on top of the melt and inserting the ladle slowly. Pouring the metal from the ladle into a controlled stream also reduces the oxides. This is an example of when you would actually be pouring into a permanent mold. As you pour, the aluminum oxides will retreat to the back of the ladle, and the aluminum will come out through the little spout, thus creating the casting. Once again, this is an example after the pouring process takes place. As you start to tilt the permanent mold, the tilting process will be like this. The oxides will go to the back of the cup, which creates a skull, and the aluminum naturally flows into the mold, creating the casting.